So probability, simple probability, like you flip a coin, is used a ton. And, you kind of sometimes do this to just sort of pick something by chance. Like roll the dice, see what we get. And I want you to remember this about probability. The first thing I told you is it comes down to what you want divided by what's possible. I'll give you an example of that. Please write that down. What you want over what's possible. Because we're going to be doing probability for 2 units. The first unit is really short, and it's basically exactly a week long. This is today, which is Tuesday. This is Wednesday. This is Thursday. This is Friday. We review on Monday. And then, I should put a M here for review. And then we test on Tuesday. So again, a week from today, we're testing on this stuff. And if I can just get you to remember that it's what you want over what's possible, I'll give you an example. There are 6 things possible when you roll a die. You guys know that, right? There's 6 sides on the die. And let's say I want an even number. Well, what are the things I want? I want it to either be 2 or 4 or 6. Then there's 3 things I want out of 6 things possible. And then this reduces to 1/2. So there's a 50-50 chance. Ooh, that's odds. 50-50 is odds. But probability is 1 and 2. All right. So what if you're flipping a coin? We need to know some words that you have to know, because on the test they're going to be like, what's the event or whatever. Event is that a certain thing happened. I rolled the dice. I flipped a coin. I did something. And then we figure out the probability from that. The next thing is the outcome is what could happen. So like if you're flipping a coin, either heads or tails are the 2 outcomes. That's what outcomes are, is what could come out. All right. Sample space is a list of all of the things that could happen. So like if you're rolling a die, you could get a 1, 2, 3, 4, 5, or 6. I just got a 6. What was the probability of that? 1 out of 6. All right. Next up, probability is the chance, and this is the number of ways it can happen. I like to think of this as what you want to happen out of the total number of things that could happen. So I think you should say it's what you want over all the possible things. So if I want heads, because, like you're calling it, and I called heads. They do this before every major league football game. I want heads, and they flip the coin. It's how many things are there that I want to happen? 1 thing that I want to happen. How many things could happen? 2 things. Okay, so it's always what you want over all the possible things. All right, so there were some important words. I'm going to keep coming back to those words to try to remind you what they are. There's a theoretical probability of an event, and that's like, that if I roll this dice 6 times, I should theoretically get a 1 and a 2 and a 3 and a 4 and a 5 and a 6. Like, that's what's supposed to happen. But is that actually what's going to happen? No. I roll the dice here. I'm going to do it 6 times. I got a 1. I got another 1 right away. That's not supposed to happen, theoretically. There was only a 1 in 6 chance I would get this in the first place. And then there was only a 1 in 6 chance I would get it again. So there was a 1 in 36 chance that would happen. But it happened. I'm going to roll again. I got a 3. I'm going to roll again. I got a 6. I'm going to roll again. I got a 4. And what would you think would probably happen next? Well, maybe a 5, because I haven't had one yet, and maybe a 2. But do you get it's equally likely that I'm just going to roll another 1? The probability is that I'm going to just roll another 1. I got another 3 instead. And another 3. And another 1. I'm going to put it in the front. That's what I actually rolled. Okay, so then the theoretical probability was I was going to get 1 of each if I rolled 6 things. There was a 1 in 6 chance of each of them. I do it 6 times. All right. So the theoretical versus the experimental probability, which is what the other kind is I just did an experiment. And for this die, experimentally, I got 1, 2, 3 out of 6, 7, 8. There was 8 rolls. 3 on 8 chance that I'd get a 3. There was a 1 in 8 chance to get a 4. Is this actually what it should be? No. That's theoretical. Theoretical is what it should be. This is when I actually did an experiment and I was getting way more 3s than I was supposed to. I got way more 1s than I was supposed to. It was a 3 out of 8 chance to get a 1. So the point is that in theory, you have a 1 in 6 chance that you're going to get any of these numbers. But when you actually do it and you do an experiment, the experimental probability is what you actually got versus what you theoretically should get. Okay, good on that. When rolling a fair 6-sided dice, what's the probability you'll roll a 4? If you've been paying attention so far, you should know this probability. Go ahead, write as a fraction. If I frame it in what I want over what's possible, what are all the possible things? Well, there's 6 of them. What do I want to happen? I want a 4 to happen, but how many things are there that I want? 1. 1 out of 6. Raise your hand if you had 1 out of 6. Okay, good. An odd number. Well, all the things I want, there's 3 of them. I could get 1, a 3, or a 5, and there's 3 of them that I want. There's 6 of them that are possible, so I bet you said 3 and 6 for that. AKA 50% or 1/2. All right? Would you please answer this last one? What's the probability I'm going to get a 2 or a 5? I win if I get a 2 or a 5. Well, how many things do I want? 2. Out of how many things are possible? 2/6. Make sense? Okay. On this spinner, what's the probability of landing on green? You might be like, well, I don't know how big that is. Well, there's 5 equal-sized chunks. So what's the probability of landing on green? Mason, I think you know. 1 out of 5. Yep. What's the probability of landing on red? 1 out of 5. What's the probability of landing on yellow? 1 out of 5. The one that was the most interesting, they didn't ask. What's the probability of landing on blue? 2 out of 5. Do you get it's more than all the others? You're probably going to land on blue. Actually, you're probably not going to land on blue. Because these 3 is more space than the blue ones. It's kind of a weird thought, but blue is the one with the highest probability, yet I will probably not land on blue. Okay. What's the probability of not landing on red? Like, you win as long as you don't land on red. Well, how many things are there that I want to do? I want to not land on red. There's 4 wedges out of 5. Who had 4 out of 5? Okay, good. All right. If you were going to pick at random one shape, I want everybody right now to just circle a shape. I don't know what you're going to circle. Just circle a shape. Just pick one. I don't care. Just pick one and circle it on your paper or on your virtual paper. All right. Now, what is the probability that you picked? Well, there could be some element of like, oh, I picked a heart because I like hearts and, you know, like that makes me want to pick them more. So it really isn't random when you picked one. I was trying to make it as random as possible to make you go do it quick. But if it was truly random, you'd have to like blindfold you and then spin the thing around and then like touch your finger in it and then that would be more random. okay? But if we did do it randomly, then what's the probability you're going to get a square? Well, I can count this real quick as 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. There's 25 things. What's the probability you're going to pick a square? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 25 is your chances of picking a square. Does that make sense to you? There's 12 squares up there out of 25. Now, I'm curious, 12 out of 25 is really close to half. Okay? I bet when we count, I bet about half of you picked a square. But we'll see. All right, please raise your hand if you picked a square. You circled one. Did you pick a square? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right, so 9 out of about 25 of you picked a square. Now, that might mean that, again, people got sucked in by like, my favorite shape is a circle. And so I picked that. And it might have been biased. How many picked a circle? Raise your hand if you picked a circle. 1, 2, 3, 4, 5, 6. 6 experimentally, 6 out of 25 of you. That was the experiment we did. Not the actual probability of the circle was 1, 2, 3, 4, 5, 6, 7, 8. It should have been more people picking circles, and there should have been more people picking squares, which means probably a lot of people picked a heart. I'm not going to make you raise your hand because some of you are going to be like, oh, I don't want to look like a, I don't know, whatever, for picking a heart. So I think that means, I know, in fact, that 9 and 6 is only 15 out of you, so that must have been the most popular shape. And it's probably because it's cute. It's a heart. All right. So, moving on. Look, they actually did a flip like I did, and they got these results. Did one come up as much as it should have? Isn't it supposed to be a 1 in 6 chance that you get a heart? Or sorry, not heart, a heads. Oh, I thought this was dice. Dang it. My bad. It's a heads and tails flips. Oopie. Sorry, you read it wrong. Heads and tails flips, not a die. So, did heads come up as much as it's supposed to? 1, 2, 3, 4, 5, 6 out of 10. Actually, it's supposed to come up 5 out of 10. But this happens. It's pretty close. All right, so then the experimental probability of heads was 6 out of 10. The theoretical is 5 out of 10. All right, I think you get the idea there. Sample space just means what are all the things that could happen? And for these, I want to give you a very simple way to do it. I bet you a lot of you have 4 different pairs of shoes at home. I'm not saying I do. I have, well, I actually might have 4 pairs, but I only wear 1, pretty much. And I think for that's maybe true for a lot of you. Maybe have other shoes at home, but just don't wear them. But let's say you had 4 pairs of shoes at home. I know you have multiple pairs of socks. And then you also have 2 pairs of boots. Now, this really messed up the problem because you can't wear shoes and boots at the same time. So this is a dumb question. All right. So I'm going to take out the boots. Just scribble them out. Now, do you get some socks might go better with certain shoes? It's true. If you're dressed up for a wedding and you have black shoes, you're supposed to wear black socks. You're not supposed to well, you can do anything you want, but it's going to match better than if you had white socks and black shoes. All right. So, if we just pick them randomly, though, all you have to do is go 6 times 4. You just have to multiply in situations like this. And there are 24 different things that could happen. Like you could wear your white socks with the green shoes. You could wear your white socks with the red shoes. You could wear your white socks with the black shoes. You could wear, so all these different things could happen, and all you've got to do is times them. I'll give you another example. You go to fast food places all the time. You go to McDonald's, let's say, and then you pick, you got 3 different kinds of burger. You got 6 different kinds of drinks. All you got to do is multiply them. You have 18 different combos. A long time ago, a McDonald's ran an ad that said something like, you can get 1 million different meals at McDonald's. It's because they took all their choices and they multiplied them. And is it really true that it's that different if that you got orange pop versus Coke? It's not that different, but it is different. And if you do that, you take all the different choices you have and you multiply them. If all they had was 6 different drinks and 3 different kinds of burgers, then there would be 18 different combos you could have. You just multiply. So, I think that's it. I feel like we're done enough. I'm going to go directly to the homework now. Because the homework's kind of lunch, and I want to give you a lot of time to get it done. Oh, wait, there's one more kind of problem that's in the homework that you have to be able to do, and that's this. Do you get that in Minnesota? There's license plates that have numbers and letters. It's really true. I'm just curious, have any of you memorized your license plate? Cool. It's probably something that'd be smart to do, because a lot of times when you're parking someplace, like you go into a hotel and they're like, what's your plate? And then you got to be like, oh, I don't know, go out and look. Okay. Back in the day, the letters were first, back when I was a kid. And then the numbers were next. And I memorized it. I was the Fez 470. And it kind of rhymed a little bit because they both start with F. Fez 470. That was my combo. Well, now it's numbers first and then letters. And I'm sure some of you have yours memorized, but I don't want you to make you say it on the video here. So how many different license plates are there? This is about how many choices they had. These are numbers. And if you think about it super quick, you might be like, yeah, there's 9 digits you could pick. 1, 2, 3, 4, 5, 6, 7, 8, 9. But what about 0? So there's actually 10 numbers you could pick. So there's 10 choices for that first number. Times 10 choices times 10 choices. That means there's 10 times 10 times 10, which is 1,000. It's only 1,000 so far. Different numbers that you could be assigned. And I mean, it feels like there should only be 999, right? Because that's the biggest number that there is. But why is there 1,000? Because 000 is also a possible combo. All right. So I want you to remember this is really important. Whenever we're doing probability, you multiply your choices. Remember, like the drinks and the hamburgers, you just multiplied them to get the right answer. Here, this is how many choices, this is how many choices, this is how many choices, you just multiply them. All right, and then how many choices are there for letter? Memorize this one yet? There's 26 letters. And then you multiply those out. And that's where you get way more possible combos. Some interesting things about license plates. Do you get that they eliminate certain letter combos? Like, who wants the KKK license plate? They don't even offer it. They will never have a KKK license plate. It's true. There's also certain letter combinations of 3 words that you can maybe imagine that they would not allow. Like they don't issue anybody the FU license plate. Okay? And there's other license plates that are just thrown out because they're just inappropriate. And there's one that a lot of people don't know about. And that's if your first letter is W. Anybody know about that one? What does that mean? Whiskey plate. That's correct. But what does that mean? I think it's you have to get multiple DWIs. Then if your license plate starts with a W, now I'm leaving plausible deniability here. I'm saying it used to be that way. I don't know if they still do this. Maybe they've stopped doing it. But when I was a kid, if it was a W on the first letter, that meant whiskey plate. And that means that a cop, by just looking at your plate, could go, I can stop that guy for any reason and just check to make sure he's not drunk because he's been caught driving drunk twice already. So that's what it used to be. I don't know if they still do that, but okay. So anyway, that's just some interesting facts about license plates. What you're going to have to do is probably figure out how many different license plates are there, and you multiply your choices. So You just multiply these all out, that's it. Now, where it can be a little more intense is if they can't repeat. Then let's just think about the numbers. If you had already picked a number for that first spot, I don't care, you picked it and you got a 7. Well, then you have less choices now. And then you've already picked one for the second spot, so you have less choices now. Do you get what I mean? If it can't repeat, then you have less overall choices, because things like 777 will never happen then. All right, how about letters? 26 times 25 times 24. Because if you've already picked a letter for this first spot, you have less choices now for this spot. So it depends if you can repeat things or not. All right, so let me give you an example. Let's say I become fantastically rich. I decide to buy a little Caribbean island, and you can do that. There's tons of them for sale. Did you know how many islands there are in the Philippines? It's insane. You should look it up sometime. It's like every one of us could have like 1,000 islands each. There's so many islands in the Philippines. But anyway, I buy an island and I decide to make some little golf carts that whenever people come to visit me, I give them a golf cart to drive around. And then why would I need license plates? I don't know. But let's say for this problem, we're going to have one letter and one number. How many different license plates could I have? Well, how many choices are there for the letter? 26. How many for the number? 10. So then it's a total of 260 license plates. That makes sense? What if I have 2-digit number? Then you got to ask me an important question. Can it repeat? Because if the number can repeat, then it would just be another 10. But if it can't repeat, then it'd be a 9. All right, so let's say instead of me being the rich island owner, I work for the rich island owner, and he has said, okay, my island's really big. I want 3-digit license plates for all my cars. It's going to be a letter in the middle and a number on either side. And that's the wealthy owner of the island is actually Chinese. And in China, the lucky number, I'm not going to go with the lucky one, although lucky is 8 in China. The unlucky number in China, anybody know what it is?
4.
4, very good. Because when you say it, the way I understand it.
I speak Chinese. So
Tell me.
The word death or dead in Chinese is si, and the number 4 is also si. So it sounds like death.
Pretty much sounds like death. And they take those things kind of seriously. Like they also, isn't the 8 one kind of like sounds like a good thing, like opportunity or?
Yeah, I would say the unlucky numbers are 3, 6, and 8.
3, 6, and 8.
There's a lot of 6s and a lot of 8s and a lot of. I don't care about 666 in China. There's a lot of 6666.
Love it. So these are lucky. So your owner of the island says, we're only going to use 3 6s and 8s on our license plate. All right, we're not going to use 4s because that sounds like death. And if the lucky numbers are 3, 6, and 8, those are the only ones we're going to pick. And also for the license plate, on letters, do you know anything about the, well, actually, these are English characters because we don't know all of the Chinese letters. Is there any letter that's particularly bad in China that you know? It probably wouldn't equate to an English character anyways, would it?
Maybe just like a letter that isn't in the Chinese dialect.
Ooh, I like that. Can you think of one?
Which is the U with 2 dots on the top of it. That's a different, that's like, I would say the one that isn't the one extra.
So let's say that no U's.
No, well, okay.
No U. You can pick any letter, but not a U. So he tells me, how many license plates can I make then? If I want to use 3 6s and 8s, and I'm not going to use U's, but I can use any other letter, but no U's. So you think your choice, oh, good question. Can you repeat the numbers? No repeating. This is as hard as it could possibly be, but at least it's kind of got some context, and it's more interesting than just a made-up number off the notes. So then you ask yourself, how many choices do I have for the first number? Jonathan, how many choices do I have for this first number here? 3. Because we're only using 3s, 6s, and 8s. All right, how many choices do I have for the letters? Say it if you know it. 25. Because you can't use U. All right, and then how many choices for the last number? Isn't it 3? No, because it said no repeating. So we already used up a number. I don't know which one we used, but we have only 2 choices left. So then there's your answer. I'm going to multiply them in this order. 25 times 2 is 50, and 50 times 3 is 150. There's 150 plates that I could make for my wealthy landowner guy. Don't worry, he pays me well, so. There's actually people that have that kind of job. Help the super rich guy do whatever he wants. And sometimes it's people in Hollywood who have like their helper person. Like, I need a latte right now. Whatever they want, their assistant goes out and does it. All right, so we can do it. Yes, probability can be weird and hard, honestly, because it's so different than normal math that this is why this is here. Because for a lot of people, this is going to be like really frustrating because you're not sure exactly what to do. On each problem, just think to yourself, is it about choices? Because if it is, you just have to multiply choices. And probability always comes down to all the things you want. I'm going to call it wanted outcomes because you now know that word. Over possible outcomes. So if you wanted an even number, for instance, there's 3 even numbers out of 6 possible things that could happen. All right. And now it's a Schoology quiz, so let's get it started. Will you please find the Schoology quiz that is in today's thing, and I think it's already there and open, so you can open it. And then once we're started and a couple problems in, you're halfway done. So let's do this. Would you read me number 1?
You create a new island in Animal Crossing, and you find that the island has 1 native fruit. The possible fruits are pears, cherries, oranges, apples, and peaches. Remember that probability is wanted outcomes over possible outcomes. What is the probability that your island has a red fruit?
Well, what do I want? I want red. Is that only one choice on our list? No, there's actually more than one red. How many red ones were there? 2 red ones. Out of how many possible were there? 2 out of 5. And you could write your answer just like that. Do you have to divide it and get a decimal? No. You can just write 2/5. 2/5. The end. On to the next problem. Jonathan, would you read me problem 2?
You roll a 6-sided die. What is the probability of rolling an even number?
Oh. How many are there that I want? How many even numbers are there on a die? 3. Out of how many possible? Just reduce it, though. So instead of 3, 6, what do you put? 1/2. All right. Porter, read me number 3.
You draw a card from the standard 52 card deck. What is the probability that you pick a card that has a heart?
All right. I'm going to save you some time. You know how many hearts there are? They're on a little picture there. 13. Out of how many cards are there total? So it's what I want, which is 13 of the what I want, over 52. And you can just leave it like that because a lot of teachers thought you wouldn't be able to reduce that. So we just said, we'll just put 13 52s in the answer. But some of you are smart enough to know 1/4, and that's also in the answer choices. All right, I think you're getting the idea. If you get stuck, there's a kid next to you with the same problems. Totally okay to talk to him. Also, come up and ask me. That's all I got for you for today.